A new study has found that increased levels of ozone in the air are linked to a rise in hospital admissions for heart attacks, heart failure, and stroke. The study, conducted over 3 years in China, showed that even ozone levels below the World Health Organization (WHO) maximum limit were associated with negative health effects. The research suggests that older people are particularly vulnerable to the cardiovascular risks associated with ozone pollution, and that climate change may worsen the situation by increasing ozone concentrations in many parts of the world. Ozone is a gas that is the primary air pollutant in photochemical smog. Unlike the ozone layer that absorbs the sun's ultraviolet radiation, ozone pollution is formed when other pollutants react in the presence of sunlight. The main pollutants that contribute to ozone pollution are volatile organic compounds and nitrogen oxides, which are emitted by motor vehicles, power plants, industrial boilers, refineries, chemical plants, and biomass and fossil fuel burning facilities. We looked at the relationship between ozone pollution and hospital admissions for cardiovascular disease. The researchers collected data on daily hospital admissions for cardiovascular disease between 2015 and 2017 in 70 cities in China, covering a population of over 258 million people. The types of cardiovascular disease studied included coronary heart disease, stroke, and heart failure, as well as subtypes such as angina, acute myocardial infarction, acute coronary syndrome, ischemic stroke, and hemorrhagic stroke. The researchers also collected data on other air pollutants, including fine particulate matter, inhalable particles, sulfur dioxide, nitrogen dioxide, and carbon monoxide. During the study period, there were over 6 million hospital admissions for cardiovascular disease in the 70 cities studied, and the average daily 8-hour maximum ozone concentration was 79.2 micrograms per meter 3. The study found that exposure to ambient ozone was associated with increased hospital admissions for all cardiovascular diseases studied, except for hemorrhagic stroke, even after controlling for other air pollutants. For example, an increase of 10 micrograms per meter 3 in the 2-day average 8-hour maximum ozone concentration was associated with a 0.40% increase in hospital admissions for stroke and a 0.75% increase for acute myocardial infarction. Although the increases may appear modest, ozone levels can surge to over 200 micrograms per meter 3 in the summer. In such cases, hospital admissions for stroke and acute myocardial infarction could be amplified by more than 20 times to over 8% and 15%, respectively. The researchers also estimated the excessive admission risk for cardiovascular disease associated with ozone concentrations at or above the WHO air quality guideline, 100 micrograms per meter 3, compared to levels below 70 micrograms per meter 3. The study found that ozone levels below 70 micrograms per cubic meter were mostly naturally occurring and not due to human activity. Compared to levels below 70 micrograms per meter 3, ozone concentrations at or above 100 micrograms per cubic meter were associated with substantial increases in hospital admissions for cardiovascular disease, ranging from 3.38% for stroke to 6.52% for acute myocardial infarction. However, even lower concentrations of 70 to 99 micrograms per cubic meter were linked to increases in hospital admissions for cardiovascular disease, ranging from 2.26% for heart failure to 3.21% for coronary heart disease. The study found that during 2015 to 2017, ozone pollution was responsible for 3.42% of hospitalizations for coronary heart disease, 3.74% of hospitalizations for heart failure, and 3.02% of hospitalizations for stroke. When each year was analyzed separately, the proportions of hospitalizations attributable to ozone pollution rose over time.